Hello everyone, I am Vagif Karimli, and this is the video for the assignment 2. So let's get started. Firstly, let's create our database. Let's go with this assignment. It's named assignment 2. Now we need to create our table. Oh no, not from here. Let's go query tool. And yeah, this is we have our numbers and text, and then the date field and ID, which is primary key and serial, so it auto increments. So let's run this, and our table is created. You can see it here. Now for the second task, we need data insertion. For that we'll need these SQL lines. Yes, this is to fill up the table. For that we can get this is our procedure. It creates random integers for number 1 and number 2, and then for the text it takes the value text and adds numbers to it, random numbers, and this is the code for our random date. And here we can choose how many records we want. Let's change it to something random. 1, 2, 3. We will have this much records. So yeah, we can run this procedure. Procedure is created, and then we can call it to fill up our table. It should take around 10 seconds. And yeah, now we can see what we have in our table. And yeah, we have our IDs, number 1, number 2, and texts, and also the date field with random dates. So yeah, we can move on to the task 3. Or no? Oh no, this is task 2. In task 2 now, in task 2 now we have to do queries, run queries without yet doing any hash indexing or b plus trees. And for that, yes, we have our code here. Yes, we can search for some text, but it would be better if we keep track of them, so let's do it this way. I'll delete this and let's have 5 values which we'll search, and let's choose them randomly. We'll be going through this and searching for this in different ways. Yeah, now we have 5 text ones. Let's run them. Yes, we run it and it took 310 milliseconds. Let's like note it under it. The second one took 299. This one took 223. This one took 232. And this one took 194 milliseconds. Let's see. Yes, now we have to do this for ID as well. We can or may not do it for field. Let's run it for this. Oh yeah, it took 347. milliseconds. And yeah, now we can run it for some IDs as well. Yeah, let's again do it randomly. Let's delete this and have this 5 times and choose some random IDs. Well, IDs are auto-incremented, so you can actually type it ourselves. Let's for instance go like this, and you can go 400,000 and like this, for instance. Let's run them and see how much time they take. For instance, this one took 205, this one took 147, this one took 120, this one took 217, and this one took 127. Overall, we can compare it with like text, which is a non-ID field, and we can also with date we can compare, and overall we can see that these queries are considerably faster, and the reason for that is that this is ID field and these are non-ID fields. Yes, this the searching for ID fields is fetched much more faster because it uses compared to just text. So now we can move on to task 3. For that we need to create hash indexes. The computer, oh no, word froze. Yeah, let's create our hash index on text 1. Let's create it on text 1. Apart from that, yes, we have searching again. For now, let's do it on text 1. Yes, now it has been created. So now let's copy the text searches which we did before and run them again and see how they perform now. For instance, this one took 104 seconds. This one took 105. I think I run the same thing. This one took 129. And this one took 20. And we can maybe add some new ones as well, maybe. Let's choose some and see. You can see 156 and 165. Yes, overall compared to the like time it took above, this is much more faster. Hash indexes helps in the searching process. Yeah, then we have to search again for the IDs as well. So let's do it as well. Okay, let's run them. 100, 144, 102. And yes, again, as we can see, the results with the hash indexing is faster compared to without hash indexing. No. Okay, now we have to do it for we did it for the text, we did it for the, I guess we have to do it again. We have to do it for the number as well. We can hash index one of the numbers, and let's see, let's do it for the number 1. And compare the results with the number 2. Let's do it this way. Yes, now it's hashed for number 1, and we can do it. Yes. And we can just search from number 2 as well, but we have to choose some random numbers. It is supposed to be between 1 and 1000, so we can write some. Yes, overall it's like that. So we can choose some random numbers. Let's say, let's choose 154. First, search it normally. On number 2, it took 264 seconds, and we can do like this. On 251, we can see there is little performance gain. We can do this again. Let me see. Yes, I'm recording. Yes, we can do it. This time let's do some like different numbers. For number 1 it took 144, and for this number it took 448, which is but here we have like some considerable time gain. Well, we tested on text, so yeah, only one remaining is date. I guess we can, yeah, let's create on date field as well. But we didn't test before, so that will be. So now firstly we have to test without hash index, and then yeah, let's drop this. Yeah, we drop this hash index, so let's search without the hash index, and then we can come back. Yes, so let's go this way. Let's not do between, but equal. Yeah, let's search this, for instance. Let's see how much time this takes. It took 304. Let's do 3 different ones as well. For instance, this one and this one. It's 344 and 240. Yes. Now let's create the hash index, and then let's run this again. Now we get 149 milliseconds, and now 135 and 159. We can run on some, like, let's run on some 2 different dates which we haven't run on before. For instance, let's choose this one and this let's run these. It took 188 and 292. Yes, again we can see that hash indexing helped with the without version of it in the speed. So yes, now we can move on to task 4. We can drop, yeah. Oh yes, now we have to drop hash index again. Let's drop it on date field. We had it on date field, and let's see, we had it on text 1 as well. Let's see where we had it. Yeah, we had it on number 1. Let's do it on number 1. And yes, we had it on text as well. Yes, and yeah, we dropped it for the text as well. Now create B plus trees. Yes, I have the code here. We can create. Oh, no. This is wrong. We don't need this. We need it on text and a number. We might. We can do it for ID as well. Let's first stick to these ones. Yes. Well, yeah, let's just run both of them. Yeah, now we create our B plus trees. So we have for number 1. Yeah, let's take some values for what we have for text. We can firstly compare it to our previous values for the text by running them. 156 milliseconds, 170. Well, this is compared to without the hash. Like this is compared to the basic version. Yes, I just checked for some stuff. Let's not do compare those, but these, it's same numbers, but here our seconds are from the hash table results. It's better to compare that, because like without anything, it's this B plus trees will of course be performing much better, but let's compare it to the hash indexing, which is what we want. Here it's yes, 157, 248. Did we actually create the index? Maybe we run it again on the text one. Oh yeah, we did it. Okay, let's run it for this. Oh yeah, here 89, 27, 106, 110, and 217. As we can see, the time it took is varied. In some places it's higher with the B plus tree, in some cases it's lower. This is normal, expected. So yes, now we can, but the thing is the B plus tree is mainly better in range function, and when some part of text is given and it looks for the rest, we will see that it performs much better compared to hash in those cases. So yeah, now we can, yeah, we did it for text 1. We can, yeah, these are for normal. We can do it for, I guess, ID or number 1. Yeah, we can do it for number 1. We did like some here. Let's copy them, create hash indexes for them, or we have more data for data field. Let's do it for data field. Yeah, let's create not hash index but p plus index. Let's just firstly drop the hash index in case we have it. Yeah, we already dropped it. So now we can create okay, let's just write it on our own for date field. Yes, for date field, let's create p plus 3 index. Yeah, it is created. Now we can compare these to the previous results. So yeah, it gives 120 when it's better compared to others here. 278, 135, 197 and 124. Yeah, as we can see, it performs better to hash indexing, and at some cases it doesn't. But now, yeah, we can move on to the point where the main advantage of b plus 3 can be seen. So yeah, our code is here. We can do this for the numbers. We can compare them. Let's go between ranges. For number 1, do we have index or no? No, we don't have b plus 3 index, so let's create it for number 1. Yes, let's create it for number 1 and compare the results to number 2. Oh, we did it already. Okay, done. We can do, for instance, let's run it for this. It took 197 seconds, but now let's do it for the number 2, which doesn't have b plus 3 index, and it took way much longer, like as we can see. Again, we can do it, we can choose some maybe different numbers and do it again one more time to see the difference. Yeah, let's change the like parameters 500 to 800. Let's do this time 500 to 800. This took, with the b plus 3, 410 seconds, but without it for number 2 it took 585. Yeah, like here we can see that b plus 3 is extremely better compared to hash indexing when it comes to finding stuff between range, as b plus 3 indexing is ordered. Now we can look at it again on text as well and for dates as well. Yeah, for text 1 we shouldn't have any indexing. Do we have? Oh no, we have b plus 3 indexing. So let's choose something else. Let's like take this, put it here, and yeah, let's run it. Let's see how much time it takes. It took 340. We cannot compare to this to anything, so I will, after doing this stuff, I will delete it, so b plus 3 index, so we can see the difference. let's choose some random dates and compare it, find it as well. For date field, again, we have b plus 3 indexing, so we can put it as well. Yeah, and now let's drop those so we can see what happens. This is name is number 1. No, it's not, but it's b3 index number 1. Yes, we dropped it, and let's do it for date field as well. Date field. Yeah, now we can test these again. This took 325, it's faster for some reason. 399, but this could be because the values are like stored in cache. We can try to run different values. Let's, for instance, 98. We run this. It took 297. We can choose maybe some other value because all of these are 97. Let's run. Let's, for instance, choose 18. Run this. It took 269. Well, in this case, for some reason, it's performing better than b plus 3, but it shouldn't. I'm not completely sure why that happens, but we can run it. Well, we can create a hash index again, and then from there compare it, maybe. Yes, overall we are finished. We can see that overall the report, let me, oh yeah, overall we can see that the b plus 3 index is better compared to hash index in when searched in range, and when comparing to when needing to find the rest of the value. As for the hash index, we can see that it is better than without it. It helps in the searching, but there is not much of a difference between b plus 3 index and hash index when searching, when using var clause for just searching. And yeah, overall that's it. Thank you for watching. Goodbye, have a nice day.